Hello dear friends, welcome my channels. Today's discussions is reasoning plus linear plus mixed problem CSIR NET gate. So first question is given that an equals to 1 by 10 to the power 100 and 10 to the power 100 log n and 1 by 10 to the power 10 n square, which is the following are true. So friends, whatever you see a n equals to 1 by 10 to the power 100 2 to the power n. Bn equals to 10 to the power 100 log n, and Cn equals to 1 by 10 to the power 10 n square. 1 by 10 to the power n square. So friends, whatever you see, limit n tends to infinity, an by Cn tends to infinity, then if limit n tends to infinity, an by Cn tends to infinity, then an greater than Cn. So friends, first we check limit n tends to infinity 2 to the power n divided by n square, it equals to infinity by infinity, then 2 to the power and now we can apply L'Hopital. Then whatever we get, n tends to infinity 2 to the power n log 2 divided by 2 to the power n. Here this portion is maximum, and this portion is minimum. So whatever we get this is tends to infinity. So whatever according to the question, so we get an greater than Cn for all sufficiently large. This statement is correct because an by Cn greater than tends to infinity, and Bn by Cn and Bn n by Cn n limit n tends to infinity, limit n tends to infinity log n by n square, and which is tends to 0, as n square is always greater than log n value. So Bn greater than Cn, this portion is wrong, and Bn greater than n for all sufficiently large. So friends, whatever you see, Bn is log n. bn is 10 to the power 100 log n, and log n is not so much increasing functions, not so much increasing functions like n, so it is obviously n. So this portion is also wrong, and an greater than bn for all sufficiently large. So an equals to 2 to the power n, and bn equals to log n. So 2 to the power n greater than log n. So an greater than bn for sufficiently large, this is correct. This is correct, friends. Now we are xn plus yn xn is convergent. So friends, xn is convergent and yn is bounded. Yn is bounded. And xn is convergent means it is the less than infinity, means finite value. Xn has finite values. So friends, whatever they say that bounded, then we can conclude it. So friends, let xn is equal to 1 by n. So it is it is convergent because n tends to infinity. Limit n tends to infinity, xn equals to 0. So this is correct. And yn equals to minus 1 whole to the power n. So xn plus yn is convergent. So xn plus yn means 1 by n minus 1 to the power n. This value is convergent or not. So friends, if you check n equals to even, then we get 1 by n plus 1, and n equals to 1, we get 1 by n minus 1. So it is not convergent, friends. This portion is not convergent. For examples we get. And now xn plus yn is bounded. Yeah, xn plus 1 by n is bounded from these equations. One by n plus 1 minus 1 by n minus 1. So this equation is bounded because it is less than 2 and it is greater than minus is greater than 0, greater than equals to 0. It is greater than equals to 2. So in my example, that it is bounded. And next, xn plus yn has no convergent subsequence. Xn plus yn has no convergent subsequence this portion is also false because Bolzano Weierstrass theorem. What is Bolzano-Weierstrass theorem? Every bounded sequence has convergent subsequence So friends, according to the questions, this portion is wrong because has a convergent subsequence and has no bounded subsequence. Convergent subsequence is tends to bounded subsequence, because every convergent sequence is bounded, but converse is not true. Means bounded is not mean that it is convergent. Like this example, 1 by n plus 1 by this example is the perfect example that it is bounded but not convergent. So number 4 is wrong. Number 4 is wrong. Again, we will discuss another problem. CSIR 2016. So friends, in this question, consider the interval minus 1, 1 a sequence n equals to 1 to infinity of elements in it. Then every limit point of n is in minus 1, 1. Every limit point of every limit point of an is in minus 1, 1, and every limit point of an cannot be minus 1, 0, 1, and every limit point of an can only be. This is the sequence. So we take an example. An equals to 1 by 1 by n. So limit n tends to infinity, an equals to 1. An equals to 1 does not belongs to minus 1, 1. So according to the question is that every limit point of an is in minus 1, 1. It is wrong because 1 does not belongs to minus 1, 1, and every limit point of an is in minus 1, 1. Minus 1, 1. For example, if we choose an equals to minus 1 plus 1 by n, so limit n tends to infinity, an equals to minus 1 So you will see that this portion is correct. Every limit point on n is in -1, 1. Number and n -1, 1. Another factor that if we choose n equals to 1 by 2n, so it is limit n tends to infinity, n tends to 0, so it is convergent subsequence. So n equals to 1 by 2. N belongs to 1 by 2. So C belongs to 1 by 5 and 1 by 5. C belongs to 1 by 2, 1 by 2. So C belongs to -1, 1. So this portion is correct, but every limit point cannot be of an cannot be -1, 0, 1. This option is false, and every limit point of an can be in -1, 1, -1, 0. This is also false, because you will see that -1, 2, 2, 1, 2, 2 is C 1 by 2. C belongs to 1 by 2. This is also a limit point. Another, friends, we will go to discuss another point. L equals to limit n tends to infinity 1 by n factorial. So friends, you have already learned that comparing test. So I apply in here comparing test. Whatever you have learned that n the comparison test ni, since this you have learned Cauchy-Adamant theorem. Limit n tends to infinity, in nth of the n equals to limit n tends to infinity an plus 1 divided by n equals to limit n tends to infinity an plus 1, means n plus 1 factorial to the power 1 by n plus 1 and divided by n factorial to the power 1 by n. So friends, in here you will see that an is equal to n plus n factorial, friends. An equals to n factorial. So power is invalid. So this is my total, and this value is equals to infinity, because n factorial divided by n plus 1 equal to n factorial. So L equals to limit 1 by infinity equals to 0. So L equals to 1 by infinity equals to 0. This is my answer. This question is coming CSIR NET June 2016. So friends, next we will solve this problem. Problem is limit problem. This is coming NBHM. NBHM MSc 2017. So friends, limit n tends to infinity, a plus 1 by n divided by a whole to the power n, and a plus 2 by n divided by a whole to the power n. A plus k by n divided by a whole to the power n, and it can be written limit n tends to infinity (1 by n whole to the power n) and a plus 1 divided by 2 by n a whole to the power n, double bond a 1 plus k by n a whole to the power n, and that equals to e to the power 1 by a plus 2 by a plus dot 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 plus k by a equals to e to the power equals to k by 2 into k plus 1. This is my answer, friends. And now this question is very important, very interesting questions. It is based on topology. Let A be the following subsets of R square, and A equals to x comma y belongs to x minus 1 whole square y square, and union x comma y x sine 1 by x. So then A is connected, A is compact, A is path connected, A is bounded. So whatever you see that, friends, S equals to A bar union B bar, such that closure of A union intersection B equals to phi, and A intersection closure of B equals to phi, then it is disconnected. So friends, it is disconnected. So first set is A. First set is a circle. First set is a circle, you see. So I just draw a circle. This is a circle where center is minus 1 comma 0 0 and 0 comma 0, and this is the 0 comma 0, and after that sine x sine 1 by x x greater than 0. So it should be this way and this way, and this is the curve. This way, this is the curve. But first I have drawn the curve. So friends, whatever you see a bar intersection B is the limit point. So limit point is 0. A closure intersection B. Intersection B is the common limit point, that is 0. Zero is their common limit point. So it is connected. And if it is continuous, then it is path connected. Limit x tends to 0, fx is equal to fx is equal to 0. So friends, whatever you see that it is path connected, continuous. So there are two fact. One is common limit point. There is common limit point is the key point, friends. Common limit point means key point. Common limit point means connectedness. And number 2, continuity. Continuity means path connected, friends. So we see it, this equation hold both two conditions. So my answer is A is connected and A is path connected. A is compact. This is not possible because it is not bounded. And A is bounded. This is also not possible because you see that sine 1 by x is not bounded, it is unbounded. This portion is unbounded, so it is not possible. Compact means closed and bounded. This set is called compact set. Now we are going to discuss topological space with cofinite topology. So friends, let R comma tau be a topological space with cofinite topology, and every infinite subset of R is, so find out. So tau equals to a subset of R subset of R such that AC is finite. This is the definition of cofinite topology, you can see that I also discuss this point. This is cofinite topology. This is cofinite topology. Definitions of the cofinite topology. Let A be infinite subset. Let A be infinite subset of R. Suppose that A is disconnected. Suppose A is disconnected, then there exist open sets B and C A be infinite subset of R, and suppose that there exists an open sets B and C such that where B intersection C equals to phi, then B intersection C complement equals to R. So B complement union C complement equals to R. So every infinite subset of cofinite topology is compact. So every infinite subset of cofinite topology, infinite subset of cofinite topology is compact. Compact why? Because it is bounded and closed. You can see it is bounded and it is closed. Compact. Next problem is, friends, very nice problem. This problem is based on argument principle. Argument principle problem, friends. So this is, now I have to draw, this is y axis 0, this is y, and this is y dash, and this is x, and it is x dash. This is the total, friends. And now after that, this position is 11 to minus 11. So this portion is, means it is the region. Region is 11 pi and 11 pi to minus 11 pi. This is the region, and x region is 0 to 1 region. So according to diagram, this portion is also removed. This portion is not correct, this portion is correct. It is 0 to 1. So it is 0 to 1, and you will see that 1 by 2 pi I integration closed integral e to the power z divided by e to the power z plus 2 dz. So these positions is, this is the comparing with the argument principle. Argument principle. What is the argument principle, friends? Argument principle told that number of zeros minus number of pole. So e to the power z plus equals to 2 minus 2. So z is equal to the value is the question is not correct. Question is minus z minus 2. So it is e to the power z minus 2. So it is z equals to log 2 plus 2 n pi I. This is the total. Z equals to 2 log 2 n pi I. And this portion is, this portion, this is the pole, log 2 plus, and now log 2 is equal to 0.64 something. So how many pole we can get? So it is, you can see that if you will count, then e to the power z minus 2 equals to 0. So it is the my counting is number of 0. I can't get pole equals to 0. Pole is 0 because if function is fz is equal to e to the power z minus 2, because this can be written this way: c f dash z divided by fz dz. It can be written this way. So argument principle wise, pole is 0. So number of zeros, where is number of zeros? Number of zeros is log 2 plus 2n pi I. Okay, log 2 plus 2n pi I. So 2n pi I means how many point you can get? You can get, it is 1, 2, 3, 4, and up to, it is total number of zeros is 11 number of zeros. So this value is 11. We can get 11 number of zeros, because minus 11 pi to 11 pi we can get 11 number of zeros. let d equals to z belongs to 0, and j mod z less than 2 pi, and f such that d tends to c, and fz equals to 3z divided by 1 minus cos z, and if z does not equals to 0, if z equals to 0, if fz n z to the power n 6a2, then value of the 6a2. So how can I get this value? So friends, this is the very simple, that 3z divided by 1 minus cos z, and cos z equals to, what is the value of the cos z? 1 minus z square by 2 factorial plus z to the power 4 divided by 4 factorial up to infinity. So I can write these positions. 3z 1 minus 1 plus z square by 2 factorial minus z to the power 4 by 4 factorial up to infinity. So friends, this portion and this portion cut, and we get 3z divided by z square by 2 factorial, and now a2 6a2, this is the Lorentz series. I have to find out f double dash 0 divided by 2 factorial. This coefficient I have to find out. So z square by 2 minus z to the power 4 divided by 4 factorial up to infinity. So it can be written this way, friends. I can take common 3z divided by z square by 2 factorial. 2 factorial means this is the 6 factorial, and it can be written this way: 1 minus 2 into z to the power 4 by 4 factorial up to infinity. So whatever I get the value is 6 divided by z 1 minus 2 z to the power 4. Oh, as I take common z square, so it is z square, so it is z square, 2z square divided by 4 factorial plus up to infinity, plus up to infinity. This is my infinity to the power minus 1. This is my value, friends. And now how can I solve this problem? Now how can I solve it? In here, what is my formula? My formula is, I apply the formula 6 by z 1 minus 2 z square by 2 factorial by 4 factorial plus z to the power 6 divided by 6 factorial. It is not z to the power 6, it is z to the power 4 up to infinity. So this value will become, f double dash means coefficient of the z. So this value is 6. Okay, another factor is when z equals to 0, so I get coefficient when z equals to 0, this value is also 6. The value is also 6, so 6. So this value is 3 because it is 6 also multiply. So A2 value is my 2 into 6 into 2 into 6 divided by 4 factorial, and this value is this value is 2 and this value is 3. So my answer is 3. So answer is 3. Nice problem. Next problem is the number of zeros. Counting multiplicity of pz 3z to the power 5 plus 7iz plus 1 in the annular region z belongs to C, where 1, this is the mark point, 1 greater than mod z mod 7. This is the annular region. So how can I solve this kind of problem? So pz equals to 3 z to the power 5 2iz square plus 7iz plus 1, must remember friends, and here you get that 2 mod of 2iz square plus 7iz plus 1 less than equals to 2 into, and mod z equals to mod z equals to 7. So 2 into 49 9 plus 7 square into 7 plus 1, that value is 148, and this portion is called gz. This portion is called gz, and fz equals to, fz is z to the power 5, and this is, and mod of gz less than mod of fz. So z to the power 5 has 5 zeros in the annular region. Next point is the friends 7iz mod of 7iz equals to 7 when mod of z equals to, in case of 1, and 3z to the power 5 3z to the power 5 plus 2i z square plus 1 less than equals to 6. Less than equals to 6. 3z to the power 5 plus 2iz square plus 1 less than equals to 6. Less than gz. You can see this portion. This is fz, mod of fz, and this is mod of gz. So by apply Roche's theory, so number of 0 is in here 1 and this is 7. So my answer is 7 minus 1 equals to 6. Very nice question. Another question is consider the following statements. Log mod z is harmonic on C by 0. Log of mod z is harmonic conjugate on C by 0. So friends, log of z equals to argument principle wise log of mod z plus I theta. Here I theta is equal to arg z. So 0 less than theta less than 2 pi. So log of z equals to, so in here you can see c is c minus 0. So whatever you see that this portion is cut. C minus 0, this portion is cut. Mod z, and mod z is also positive. Mod z is always positive. So we use branch cut. We use branch cut. So whatever you see, when we see branch cut, so it is the 2 pi and it is minus pi, and this is the removing part. This part is removing. I remove this part as log of mod z is harmonic. So whatever you see, log of mod z is harmonic, but log of mod z is not harmonic conjugate. Why? Because when harmonic conjugate, then when it is harmonic conjugate, then it is analytic, but we can't get any analytic functions, but we can't get any conjugate number, so it is not harmonic conjugate on C by 0, means it is not analytic, friends. And now reasoning math 77654. So 7 plus 4 equals to 11. So you get 11 minus 11 equals to 0. You get 8 plus 4 12 and 13 minus 12 equals to 1, and this portion 11 plus 2 minus 2 equals to 11. So this portion is 11. So my answer is 11 is my answer. Now we will solve the last problem, question number 13. That let A is equal to n comma r, where n greater than equals to 2. Which of the following are true? So whatever you see, we know that a to the power m equals to 0, then that implies A is nilpotent matrix. A is nilpotent matrix. And a to the power k equals to 0, so then k is less than equals to n, where n is order of matrix. And a to the power n a to the power n equals to 0, then k equals to n. This is order of that implies order of matrix. So a square my first option is correct. First option is true because a to the power k equals to n means order of the matrix. K value is less than equals to n. But here 2n is greater than n, so it is a to the power n equals to 0 is true. It's true. Now a equals to 1 comma 0 comma minus 1, but a square is equal to I. So it is not a does not equals to plus minus I. So this portion is also wrong, and a to the power 2n equals to I. A to the power 2n equals to I, then a equals to plus minus I. This is also wrong. Why? Because you will see that a to the power 2n equals to a to the power 6 equals to I, and a to the power n equals to a cube, that is a square into a equals to a square equals to a, and a cube equals to a does not equals to I, as a square is also I.